This is Dr. Holt. This video is on where you have a position versus time graph and you want to draw a velocity versus time graph. Okay, so I want to talk a little bit about what to do here. On this case, you have a particle is located at x equals 2 and time equals 0. The particle's initial velocity is 2 meters a second. I'll get a red pen here and look at this. Now you notice here each tick mark here is represent 2. So if this is 2 here, then you should see a 2 right here. That means at time equals 0, I'm at 2. Alright, so let's go ahead and just label some times. I'm going to come over here, 1, 2, 3, 4. I'll make this will be 4 seconds here. I'm basically hitting all my vertexes. 5, 6, 7, 8, 9. That would be 9 seconds here. 10, 11, 12, 13 here. That would be 15 here. And then we got 18 right here. Alright. Now when you have a position versus time graph or displacement versus time graph, this area underneath this is irrelevant to you. You're not going to be calculating the area under a position versus time graph or displacement versus time graph. You're not going to be doing that. You will calculate the area of a velocity versus time graph and acceleration versus time graph, but not a position versus time graph. Alright, now if you have a position versus time graph and you want to draw the velocity, what you're going to do then is find the slope of your lines if you can. If they're linear, you can do that. So we're going to do that first. What you want to do here is find out how far do you rise. Now this is each tick mark going up is going to be 2. So it's going to be 2, 4, 6, 8, 10, 12. So this point here would be 4, 12, meaning I've come over 4 and I've gone up 12. Now what you don't want to do is say, wow, the slope m must equal to 12 over 4 and you get 3. Okay, that's incorrect because the slope of this line is not 3. You need to come down to this other point and look at that point. The coordinates of it are going to be 0, 2. So when you calculate the slope of this line, let's go back and fix this. It's going to be this value here minus this value here. So 12 minus 2 over the change in time, which will be 4 minus 0. That's going to give me 10 over 4, which is equal to what? 2.5, right? So my slope's 2.5. Alright, and all I'm doing here is basically from Algebra 1 is I'm just taking the slope y2 minus y1 over x2 minus x1. That will always give you slope. Okay, so we're at 2.5. Alright, so now all I have to do, I'll do this in black, is we want to find 2.5. So each one of these tick marks is 1 meter a second. So I come up 1, I come up 2, I stop right there. Now, this slope is the same everywhere, between 0 and 4 seconds. So I'm going to come over to 4. 1, 2, 3, 4. I'll put a mark. I'll come up here, put a mark. All this is going to look like is going to be a straight line between here. That again. Straight line between here and here. Let's see if I move it down a little bit. Okay, and that's what your velocity versus time graph is going to look like for the between 0 and 4. And I'll label this too. Slide this back, and we can label this as being a value of 2.5. Okay. Now, if you're asked, what's the instantaneous velocity at 2 seconds? Well, you come over 1, 2, you come up 2, you can look at this and say, wow, it has to be the same slope. Because if I draw a line that is parallel or tangent to this line right here, it's going to have the same slope. So it would also be 2.5. Or you can go to your velocity versus time graph, come up here, look at 2, go up, and you say, wow, it's 2.5. That's all you got to do. Anytime you see a linear line then the instantaneous is going to be the same as the average velocity between the 2 points. Alright, now let's work with the next one. We're going to work this line here. We go back to red and we're going to find out the coordinates right here. The coordinates here, we know we're at 9. We know we were going up by values of 2. We are at 12 here, so it's going to be 14, 16, 18. That's going to give me a value of 18. That gives me a value of 9. And again, whatever you do, don't say the slope of this is 18 over 9, because it's not. Go back and let's calculate it one more time. I'll get rid of this. Get a larger eraser. So we go back, we do 18. We're going to minus the end of this point, which is 12. Over my time intervals of 9 minus 4. When I do that, that's going to give me 6 over 5. So 6 over 5 is equal to, what is that, 1.2, yes, 1.2. So what I'm going to do is I need to go down and find 1.2, and we're going to, I'll do this, just put a mark here. Each one of these is going to be 1, so 1.2 would be somewhere right in here. And again, that's going to be valid between 4 and 9. So that's 4, 5, 6, 7, 8, 9. Put a tick mark right there. And now all I have to do is draw a straight line between there and there. And I come straight down here too. It just drops down. Okay? And that's what your velocity time graph would look like between 4 and 9. Oops, I'll label that different color. And I'll go ahead and put some times on here. So that's 9 right there, and that'll be our 4 right here. And again, that value right there would be 1.2. Alright, now let's work down here. Let's see if we can find this, what the slope of this line is going to be. Do that back in red, and we know this value, again, we're back to 12. So that's going to be 13, comma, 12. We find the slope of that line. We'll erase this again. Oops, erase this. Put in the values of the slope. Again, we take this value here, which is going to be 12. We're going to subtract this value here, which is 18, over the time intervals of 13 minus 9. 12 minus 18 gives me a minus 6 over 4, which will give me a minus 3 over 2, which is equivalent to negative 1.5. Now you notice here this slope is going down, so we know, wow, that has to be, we've got to have negative slope, which we do. So now I'm going to go down and find 1.2. Each of these tick marks, sorry, find 1.5. Each of these tick mark is 1. So I know it has to be right in there. So I'll come over here. I'm going to move this 9 out of the way. I'm going to move it back to the top because we're going to run right through it here in just a second. I'll erase this to put the 9 back in black, and then put this tick mark over here. Again, I want to go over to 12. That's 10, 11, 12. I'm going to come down here, put my tick mark here, put my tick mark right there, because again, that represents a negative 1.5. And I'll draw a line between here and here. Come straight down to here. Alright, I'm just about done here with this velocity versus time graph. I got to do this interval and this interval here. And again, we will label that part as, that would be negative 1.5. Alright, now notice what happens between 13 and 15. I have no change in the y value, so my slope here would be 0. So come up here, this is not 10, 11, 12. Let's see if I get this right. 10, 11, 12. I didn't go over quite far enough. Let's go over a little bit further. Sorry about that. Let's go over one more. Make sure you don't make the mistake I made. That's 10, 11, 12, 13. That mark there would be 13 right there. 10, 11, 12, 13. Okay. So now we're set. Now we're going to go back, and we're going to be flat between 13 and 15. So we come back up there, and then we go back over to here. And I'm going to change this to a different color, all of these, if I can. I think it's going to help you because it's starting to bleed together a little bit. Okay, so that's what my velocity versus time graph would look like, and now the only thing I have left to do is to do this one. We'll go ahead and identify these points again. We said this point here is going to be that's 12, that's 15, comma 12, and now I'm back down to here of 0, comma 18. We find the slope. Let's erase this one. Put the values back in. Again, you always take final position, which in this case is going to be 0 minus your 12 over the time interval of 18 minus 15, which is going to give me minus 12 over 3, which gives me minus 4. So that means I'm going to have to find 4, negative 4, so I come down 1, 2, 3, 4. I know I'm going to be along this line here. I come straight over. I'm going to be down here. All I got to do is draw my line. We'll come straight down here. And we come straight over. And that's it. That is your velocity versus time graph. Now you could go ahead and label this as negative 4 to be consistent. Okay. Now you can go back and you can prove to yourself that this is correct. So let's figure out what the area under this curve would be from here through here. So we know we're at 2.5. Our length is 4, so 2.5 times 4 is 10. So we go back, we know we were at 2 before, so we take this area here, total, we said was 10, we added 2, and we better get 12 for our position, which we do. Same way here, we calculate the area across here. This length would be 5 times 1.2. 5 times 1.2 is 6. I better be able to add 6 onto 12, and I do, and I get 18. And you can double check yourself. So that all the areas under here, if I calculate all the area here, add it, and then subtract this area, and then subtract this area, add it back onto 2, you will get back to 0. That's the way it works. So let's just talk about this one again. The slope of the position versus time, or displacement versus time graph, will represent these values along the y-axis, or represent the velocity of a velocity versus time graph. The area under the curve of velocity versus time graph will represent the y values of the position. As long as you take those values, you add it back into the initial position, you can get the actual position of the particle. Alright, let's look at one more thing I want to talk about. Well, hang on one second. Let's talk about one more thing here. When you have a velocity versus time graph where all the lines are flat, then you cannot draw an acceleration versus time graph. Your acceleration is going to be 0 throughout. So if you see linear lines in your position versus time graph, you will not have acceleration. Where you're going to have acceleration is if you see a curve like this. If you see a curve like this, then you're going to have acceleration. Here, here, here and here, you will have no acceleration. The acceleration will be 0. Now what you could do, if you wanted to draw a velocity versus time graph on this, if you could draw tangent lines to the curve and then determine what the slope of each one of those points would be, for example here, here, and here, then you could draw yourself a linear line going back through those points, and you could actually draw your velocity versus time graph. But again, you would have to be able to generate these slopes of these lines here. You wouldn't have any trouble with these because you can find these slopes because they're linear. Alright, this video again basically is just covering the position versus time graph and how to go back and draw the velocity versus time graph. I hope this helped you guys.